Hello, and thank you for joining me today. In this presentation, I will be sharing instructional strategies for effectively implementing Big Ideas Math Algebra 1 curriculum. The goal is to highlight how the curriculum supports student understanding, engagement, and real-world application, while also offering practical strategies teachers can use right away in the classroom. Why Big Ideas? Big Ideas was selected because it is a standard-aligned and research-formed curriculum that emphasizes both conceptual understanding and procedural fluency. Rather than focusing on memorizing isolated steps, the curriculum centers on instruction around key algebraic ideas that repeat and deepen across the lessons. By focusing on the big ideas of Algebra 1, such as the relationship between variables, functions, and patterns, students can begin to see concepts connect and build upon one another. This approach helps students develop a stronger foundation and deeper understanding in algebra as a coherent system. Students are given the opportunities to explore it before structured examples are done, and then there is time for discussion for students to talk the math. Big Ideas Math closely aligns with constructivist learning theory, which emphasizes that learners actively construct their own understanding instead of being told how to solve a problem. Students are encouraged to explore, make predictions, reflect, and test ideas. Students become active participants rather than passive learners. A strong example of constructivism in Big Ideas Math can be seen in lessons on linear functions. Students might begin by analyzing patterns through exploration and calculate while working with a partner, then creating their own data to analyze. Through graphs, tables, and discussions, they identify patterns and relationships for being formally introduced to the equations needed to find slope-intercept form. By discussing patterns first and formalizing them later, students develop stronger reasoning skills and a clearer understanding of why algebraic rules work, not just applying them. Two instructional models that work especially well with Big Ideas Math are problem-based learning and cooperative learning. Problem-based learning allows students to engage with authentic, meaningful problems that require critical thinking and multiple strategies, where cooperative learning allows students to work in small groups, discuss ideas, and learn from one another. Together, these models refine student engagement with deeper thinking. One effective strategy is something called the jigsaw activity. In this approach, students become experts on a specific part of a lesson, such as graphing, interpreting, or finding slope. And then the students will teach that concept to their peers. This strategy increases accountability, motivation, while students' communication skills are developing. Students learn to connect more deeply because teaching requires them to organize their thinking and explain ideas clearly. Another powerful strategy is using real-world problem-based tasks. One example is students can explore what happens to the elevation of a submersible exploring the ocean floor over time. These tasks encourage collaboration, critical thinking, and problem solving while helping students see how algebra connects to real-life examples such as science. When students see relevancy, engagement and persistence naturally increases. Technology can further enhance instruction, especially tools using Desmos, the online graphing calculator. Desmos allows students to visualize functions, manipulate variables, and see immediate results. This real-time feedback supports inquiry-based learners and lets students test ideas quickly. In the classroom, Desmos can be used for exploration, discussion, and formative assessments, making abstract concepts more accessible. For online or hybrid learning, platforms such as Google Classroom or Edmodo are effective supports. These tools allow teachers to distribute assignments, facilitate discussions, and promote immediate feedback. They also create opportunities for collaboration beyond the classroom, ensuring continuity of learners and communication regardless of setting. To summarize, Big Idea combines structured content with student-centered strategies to promote engagement and understanding. Using instructional models like problem-based learning and cooperative learning, students can make meaningful connections and stay motivated. When paired with purposeful teaching and technology, the curriculum supports both in-person and remote learning environments while keeping the students actively involved. Thank you for watching and engaging with this presentation. I hope you feel more confident and supported as you implement Big Ideas Math Algebra 1 in your classroom. By focusing on big ideas, student exploration, and real-world connections, we can help students build strong algebraic thinking skills that last beyond the course.